In this video, we're going to talk about the biological effects of radiation. Previously, we said that unstable nucleus is radioactive and it emits the radiation, and it might do this emission differently. For example, if the nucleus is too big, it can emit the alpha particle. The alpha particle is a particle which contains the two protons and two neutrons. So if the number of the protons is too much, so if the nucleus have too many protons, then some of its protons spontaneously becomes a neutron. In this case, the nucleus is going to emit the beta particle. So in this case, it's going to emit the positron with the mass 0 and with the charge 1. So you can see that if you just add up this neutron with the neutral charge to the positron with a plus positive charge, so we are going to get the proton here. So it is possible also that if the if the nucleus has too many neutrons, then some of its neutrons becomes positron spontaneously. In this case, the nucleus is going to emit the electron with the -1 charge with the mass 0. So you might see from here is that, so this proton with this electron in combination with this electron is going to give us the neutron. So positron with a plus charge in the combination with the electron with the negative charge is going to give us the neutron. And there is a third type of the radiation when it emits the gamma photons, highly frequent gamma photons. So far, we know about 4 different instabilities. So different instabilities are going to produce the different types of the radiation. So if the nucleus have too many protons, then it's going to emit the beta plus radiation, or the positrons with the charge 1 and mass 0. If it has too many neutrons, it's going to emit the beta minus radiation, or basically the electron with a negative charge and a mass 0. If the nucleus is too big, then it's going to produce the alpha particles, or the helium, with the mass 4 and with atomic number 2, basically with the 2 protons and 2 neutrons. And if the nucleus is too excited, it's going to produce just the gamma particles with the 0 mass and 0 charge. So no matter what kind of radiation it produces, so it's always is about the ionization, right? So we are going to have the free electrons or free protons, which are going to annihilate at some point with some electron. It is going to produce again the highly energy gamma photons. So those gamma photons is dangerous for the for the human organs, because so it's going to hit some DNA at some point, and it may crush the connections between the strips of the DNA, which can lead to the mutation. So in our organs, most of the elements have the natural isotopes which emits the radiation, actually, even in our human body, even the carbon, hydrogen, or the oxygen. So they emit the radiation every second inside our body. And luckily, we've got the enzymes which repairs the DNA from the damage as it happens. But if we are under the highly radioactive substance, which emits the radiation with a really high frequency, so our body is not cannot repair itself as it happens. So it may lead, so those mutated cells may lead to the cancer cells. So this is just the summary about the radiation. Let's do a couple of exercises on nuclear reaction of the elements. So let's say we've got the potassium with the atomic mass 42. So it's going to emit some electron with the negative charge -1. So what kind of element we are going to have here? So the unstable nucleus is becoming stable, and it emits the electron. So in order to know what kind of element we're going to have here is, we just need to like make it here 20, right? Because the 20 and minus 1 becomes 19. And since the electron doesn't have a mass, so the mass is going to still have the 42. So we need to go to the elements table, and we see that this is going to be calcium. So was the atomic number 20, and it's going to emit the electron was the minus 1. So let's go to the second problem. 84. We've got the polonium was the atomic number 84. So it's going to produce the lead was the atomic number 82. So it's going to produce the lead with the atomic number 82. So what we would like to do is what kind of radiation it produces. So it's going to produce the alpha radiation, right? Because its atomic number should be equal to the 2 here, and its atomic mass should be equal to the 4. So if you basically sum them, so if you sum the atomic numbers, it's going to be 84. If you sum the mass, it's going to be 210. So in this case, this nucleus is going to produce the alpha radiation. So let's go further. So we got beryllium was atomic number 4 and was a mass 9. So it produces, again, the beryllium was the atomic number 4 and it was a mass 9. So what kind of radiation it produces? So its mass and the atomic number is not changing. It means that it's going to produce the gamma radiation with the 0 mass and 0 atomic number. So we've seen here so far, so the beta negative radiation. So here we've got the alpha radiation. So beta radiation, it means that the nucleus have too many neutrons, right? So it's some of its neutrons becomes a part proton. So the alpha, it means that it's too big. So the gamma radiation, it means that it's too excited, so that it just like releases some of its energy. And the next one, so I've got the carbon was the atomic number 6 and it was a mass 13. So in the combination of the positron was the 1, was the atomic number 1 and it was a mass 0, what kind of element it's going to produce. So we just need to add the atomic numbers. It's going to be 7 here. And then we went to got the like a sum of the masses. We've got 13. We go to the table, periodic table, and we see that this the element with the atomic number 7 is going to be nitrogen. So it's going to produce the nitrogen. So this is about the beta plus radiation. Cool. So let's say I've got the aluminium and I'm going to like emit. So absorb the electron, right? So in this case, it's not going to emit the electron, it's going to absorb the electron. And what kind of element it's going to produce? So basically the atomic number becomes 12 and the mass is 26. So we need to go to the table and look for the element with the atomic number 12, which is going to be magnesium here. Right? So actually this is not the emission of the radiation, it's going to be absorption of the radiation. So some of the nucleus is going to absorb the electron, so the beta particle, and it's going to produce another nucleus, another element.